I am re-recording this particular piece of Chapter 9 in Sustaining the Commons because I had made an error in the way I explained this graph. We are still talking about self-governance, and we were looking at common pool resources, and we had set up a situation where arena action situation where multiple stakeholders or users are exploiting a common pool resource. There is subtractability. If someone takes something, it's not available to the other player and so on. But it was about balancing between wage earnings and getting something from the common pool resource. You can imagine that you are working in some job for a living, but you're also trying to earn some extra bit of income by fishing in a local water body that's shared with others, let's say. So we talked about how to calculate the wage and the optimum choice between individuals and as a group. Obviously, if everybody goes to fish in that pond, you're going to exhaust the fish, and it's going to be a tragedy of the commons. And here we are going to put a bit more detail on it. We are looking at the value function for different levels of sum of efforts is depicted in this blue color. So earnings from the common pool resource, you can see that sum of investments in CPR is what we called it. People spending time to catch a fish or to use irrigation water to set it up and make it work, etc., are investments. And you start with zero, and then everybody begins to increase their investments or number of hours spent in using the common pool, harvesting the common pool resource, and the group earnings keep going up. So everybody gains in the beginning when they are still not at the full capacity of the common pool resource. But everybody is starting with an endowment, which means everybody has been given a certain number of licenses to fish, or a certain amount of water they can withdraw from the irrigation pond, and so on. So you can imagine there are many ways to set up the endowment. In a lab game, obviously you'll be given 10 tokens to play with the others. And the big difference here is you can do it without telling each other what you are doing. So information is only based on what you know about the common pool resource, and you know that there are others also harvesting the same resource, but you are not coordinating with each other because you are not communicating with each other. So you can keep on increasing the group earning, everybody's earnings together. So you started with an endowment and you keep building on top of it, and you keep harvesting the earnings from the common pool resource as well. But if everybody continues to harvest, at some point you're going to reach the peak production from peak harvest from the common pool resource, and the earnings also keep going up and they peak and they can stay there for a while. But eventually, if you harvest too much from the common pool resource, then the sum of investments has to drop because there are just not enough fish. Okay, so earnings also begin to drop, or you can think that maybe people are just not spending beyond 24 hours fishing. Okay, you can think of it in multiple ways. And then the investments drop after everybody has peaked their time spent on harvesting the common pool resource. So net earnings also begin to drop because you have the endowment and then you have earnings from CPR, and they together drop. What's the big deal? The big deal is that you can then add other details. You can change the CPR action situation. In the baseline experiment, we said the results will change if we make small modifications to the action situation, which is harvesting the common pool resource. These changes, somebody has to ring the bell right now, so I have to stop. Maybe a delivery, excuse me. Surely enough, it's Amazon delivery. I won't say what it is, but anyway, it's important piece of daily usage item. Okay, so hopefully I'm recording again and continuing. So we can change the situation where we allow communications between the players, in this case the users of the common pool resource, and you can do it in many ways, that there is constant open communication even as they are fishing together, etc. Or you can say they come together, they discuss the situation, they make some agreements, everybody agrees to fish so much or spend so much time fishing, because you cannot guarantee how many fish you will catch even if you spend the same amount of time, and so on. And it turns out essentially that when there is, so they communicate, they decide on something and they go off, and then there is no communication. They are fishing and they are not communicating with each other. Okay, and you cannot see what the other person is doing, but you believe them because they are people that promised you something. And it turns out that there is something called cheap talk, which describes the agreements and promises that are not enforced. So people agree to something and then they can go and break their word, but you can't do much about it. Except it turns out again that as people are not always maximizing self-interest, they are not rational egoists, they are also bound by peer pressure, reputation, etc., so that they do not break their word in general. Okay, of course it happens in the real world. So promises cannot be enforced and the decisions are private. If participants' decisions were known to each other, there might be reputation effects, like people getting bad feedback on eBay, which means you are selling stuff on eBay. You may misrepresent the item with a photo and you may sell once and get away with it. But if you are caught selling, making misleading claims of the items you're selling, soon the reputation will get bad and you will suffer, right? So average investment level per person in the common pool resource, the dotted line represents the average plus minus standard deviation. So you keep repeating the rounds of harvesting the common pool resource after each communication, and you see that the investment in CPR only goes up slightly, goes up or down a little bit, but not much in some units in terms of, let's say, the time spent or amount of water withdrawn and so on and so forth. Okay, so what happens if you allow communication? So distribution of the investment levels into the CPR, these are the number of units in investment and these are the frequencies, which means how many times this happens in these multiple cycles of communication harvesting. You can see that investment in CPR 10 at maximum is about 35 to 40%, and rest of them fall off very quickly, and then there are some people who will invest no time at all, so that frequency is non-zero. One is, for whatever reason, is 0, and then it increases and then it jumps here at the full investment of the endowment. Let's say 10 is the endowment you start with. Okay, so the opportunity for repeated face-to-face communication was extremely successful in increasing joint returns. The group earnings go up. In the 10 token experiments, which is what the 10 is here, you are spending all the tokens on harvesting the common pool resource. Participants obtain close to 100% of the maximum available returns. So if you can calculate just how much earning can be made from common pool resource, everybody was basically close to the maximum. Only in 5% of the cases did a participant invest more in the common pool resource than was agreed upon, so cheated, let's say. The results show that a random group of undergraduate students quickly reached the group maximum, while the prediction using the rational egoist model was that they would still over-harvest the resource. Just think about it. They are not over-harvesting, even though communication is not constant. They agree upon something, they stick to it, and the group earnings go up just automatically. It's not a planned optimization experiment. So the predictions using the egoist model says they would over-harvest it and will lead to tragedy of the commons. Although there was no formal punishment possible, participants used strong language if they detected somebody had invested more than what was agreed upon. So people are not supposed to say anything, but they will give a harsh look or use harsh words, right? The participants had probably internalized the norms regarding the importance of keeping promises. They were also not shy to express anger if participants broke their promises, and those who did promised to do better next time around, so they felt the peer pressure and so on. So we'll come back and discuss costly sanctioning, but what is internalizing the norm? This is something very common to generally human beings, but maybe also to our ancestors, chimpanzees, gorillas, etc. And the idea is that when there are rules, you just internalize them, which means you automatically follow them even when nobody is watching. In this case, it was about harvesting the common pool and doing what you agreed to and not cheating. And there are many examples. For example, you can be in a small town, one intersection with a traffic light. It's midnight, nobody is around, cops gone to sleep, and you know that it's safe to break the red light, but you will not break it, you will wait. And whatever the timing, the light changes and then you go. This is called internalizing the norm. Obviously, there will be people who will be breaking the red light even when there is a camera and a cop. So we're not talking about free riders, but we're talking about the general population tends to stick to their word and internalize the norms, which also are the promises they make in common pool resource situations. Okay, beautiful work, and we have a lot to learn. So we'll keep building on this and see exactly what we mean by institutions, actions, action arenas, players, action situations, norms, and it's not just common pool resources. We will look at public goods, and the institutional analysis and development will get into more details on all these situations together to make pathways to sustaining the commons. Okay, so again, we are not just rational egoists. We are able to consider the welfare of the others. Key message.